although I can't recall ever having kissed a photograph, I have wept when reading poetry, when listening to music. I think that those on this side have come to rather resent the suggestion that religion has a monopoly on emotion, on poetry. On sympathy, on empathy. Everybody in this room, I dare say, has felt deep grief at the sight or the thought of a suffering individual somewhere in the world, maybe even of another species.
But up there in the cosmos, an inescapable perspective awaits. National boundaries are not evident when we view the Earth from space. Fanatic ethnic or religious or national identifications are a little difficult to support when we see our planet as a fragile blue crescent fading to become an inconspicuous point of light against the bastion and citadel of the stars. How would we explain all this to a dispassionate extraterrestrial observer? What account would we give of our stewardship of the planet Earth? We have heard the rationales offered by the superpowers. We know who speaks for the nations, but who speaks for the human species? Who speaks for Earth? From an extraterrestrial perspective, our global civilization is clearly on the edge of failure in the most important task it faces, preserving the lives and well-being of its citizens and the future habitability of the planet. We've reached a point where there can be no more special interests or special cases. Fundamental changes in society are sometimes labeled impractical or contrary to human nature, as if there were only one human nature. But fundamental changes can clearly be made. We're surrounded by them. In the last 2 centuries, abject slavery, which was with us for thousands of years, has almost entirely been eliminated in a stirring worldwide revolution. Women, systematically mistreated for millennia, are gradually gaining the political and economic power traditionally denied to them. And some wars of aggression have recently been stopped or curtailed because of a revulsion felt by the people in the aggressor nations. The old appeals to racial, sexual, and religious chauvinism and to rabid nationalist fervor are beginning not to work. A new consciousness is developing which sees the Earth as a single organism and recognizes that an organism at war with itself is doomed. We are one planet.
What bird has the most elaborate, the most complex, and the most beautiful song in the world? Well, I guess there are lots of contenders, but this bird must be one of them. The superb lyrebird of southern Australia. He clears a space in the forest to serve as his concert platform. To persuade females to come close and admire his plumes, he sings the most complex song he can manage, and he does that by copying the songs of all the other birds he hears around him, such as the kookaburra. It's a very convincing impersonation. Even the original is fooled. He can imitate the calls of at least 20 different species. He also, in his attempt to outsing his rivals, incorporates other sounds that he hears in the forest. That was a camera shutter. And again. And now a camera with a motor drive. And that's a car alarm. And now the sounds of foresters and their chainsaws working nearby.
Already, cities like Miami here are under threat. Scientists predict that by the end of the century, the sea level's going to have risen by 1 meter or even 2. Were that to happen, parts of this city would certainly be submerged.
Around the world, hundreds of millions of people live near the coast, and as sea levels rise, their lives will be seriously affected. It's now clear that our actions are having a significant impact on the world's oceans. During the 4 years it took to make this series, we've witnessed many of these changes firsthand. But we've also worked alongside men and women dedicating their lives to safeguarding the ocean's future.
The oceans provide us with oxygen, they regulate temperature, they provide us with food and energy supplies, and it's unthinkable to have a world without a healthy ocean.
I still think we have the capability to change the manner in which we're wasting the resources, in which we're poisoning our oceans, and we can look to a future with healthy oceans.
When I look forward, I believe that if what we are doing can be duplicated just a little bit, these animals will have a chance of surviving.
It comes down, I think, to us each taking responsibility for the personal choices in our everyday lives. That's all any of us can be expected to do. And it is those everyday choices that add up.
We are at a unique stage in our history. Never before have we had such an awareness of what we are doing to the planet. And never before have we had the power to do something about that. Surely we have a responsibility to care for our blue planet. The future of humanity, and indeed all life on Earth, now depends on us.
The atoms like each other, the different degrees. Oxygen, for instance, in the air would like to be next to carbon, and if they're getting near each other, they snap together. If they're not too close, though, they repel and they go apart, so they don't know that they could snap together. It's just as if you had a ball that was trying to climb a hill and there was a hole it could go into, like a volcano hole, a deep one. It's rolling along, it doesn't go down in the deep hole, because if it starts to climb the hill and then rolls away again. But if you made it go fast enough, it'll fall into the hole. And so if you have something like wood in oxygen, there's carbon in the wood from a tree, and the oxygen comes and hits it, carbon, but not hard enough. It just goes away again. And, the air is always coming, nothing's happening. If you can get it faster, by heating it up somehow, somewhere, somehow, get it started, a few of them come fast, they go over the top, so to speak, they come close enough to the carbon and snap in. And that gives a lot of jiggly motion, which might hit some other atoms, making those go faster, so they can climb up and bump against other carbon atoms, and they jiggle, and they make mothers jiggle, and you get a terrible catastrophe, which is one after the other. All these things are going faster and faster and snapping in, and the whole thing is changing. That catastrophe is a fire. It's just a way of looking at it, and these things are happening, they perpetual, once it gets started, it keeps on going. The heat makes the other atoms capable of reaching to make more heat, to make other atoms, and so on. So this terrible snapping is producing a lot of jiggling. And if I put, with all that activity of the atoms there, and I put a cup of coffee over that massive wood that's doing this, it's going to get a lot of jiggling. So that's what the heat of the fire is. And then, of course, if you see, this is what happens when you start to think. You just go on and on, wonder how did it get started? Why is it that the wood's been sitting around all this time with the oxygen all this time, and it didn't do this earlier or something? Where did I get this from? Well, it came from a tree. And the substance of a tree is carbon. And where did that come from? That comes from the air. It's carbon dioxide from the air. People look at trees and they think it comes out of the ground. That plants grow out of the ground. But if you ask where the substance comes from, you find out, where do they come from? The trees come out of the air? They surely come out of the air. No, they come out of the air. The carbon dioxide in the air goes into the tree, and it changes it, kicking out the oxygen and pushing the oxygen away from the carbon and leaving the carbon substance with water. Water comes out of the ground, you see. Only how did it get in there? It came out of the air, didn't it? It came down from the sky. So in fact, most of a tree, almost all of the tree is out of the ground. I'm sorry, it's out of the air. There's a little bit from the ground, some minerals and so forth. Now, of course, I told you the oxygen, we know the oxygen and carbon stick together very tight. How is it the tree is so smart as to manage to take the carbon dioxide, which is the carbon and oxygen nicely combined, and undo that so easy? Ah, life. Life has some mysterious force. No, the sun is shining. And it's the sunlight that comes down and knocks this oxygen away from the carbon. So it takes sunlight to get the plant to work. And so the sun all the time is doing the work of separating the oxygen away from the carbon. The oxygen is some kind of terrible byproduct, which it spits back into the air, and leaving the carbon and water and stuff to make the substance of the tree. Then when we take the substance of the tree and stick it in the fireplace, and there's all the oxygen made by these trees, and all the carbon would much prefer to be close together again. And once you let the heat to get it started, it continues and makes an awful lot of activity while it's going back together again. And all this nice light and everything comes out, and everything is being undone. You're going back from carbon and oxygen back to carbon dioxide. And the light and heat that's coming out, that's the light and heat of the sun that went in. So it's sort of stored sun that's coming out when you burn it, a log.
It's interesting when you talk about how he was sitting there doing it with a pencil and paper and his imagination. Again, that other saying that's often attributed to him, that imagination is more important than knowledge. It's hard to believe that he would say that, except he accomplished so much with his imagination based on the knowledge he had. And in the piece tonight, he talks about that moment when he imagined a man falling off a building.
Happiest thought of his life?
Happiest thought of his life. Why was that the happiest thought? Because that sounds like he's saying it's the most central image to all his thinking.
Yeah, that was the key idea that propelled him toward the general theory of relativity. See, gravity is a difficult subject. It's hard to even figure out a way in to a description of the force of gravity at the level that Einstein was searching for. What he realized was that a certain kind of motion, freely falling motion, in essence counteracts gravity, can eliminate gravity, which means in any situation where there's gravity, if you don't want to have to deal with it directly, just execute a certain kind of motion. Jump out a window, and then gravity goes away.
What? You jump out the window, gravity makes a quick entrance.
Actually, it doesn't. It doesn't. So you jump out the window, what actually happens from Einstein's perspective is that the ground is just rushing up and hitting you. You're not being pulled down by gravity from Einstein's perspective. I mean, when Newton was sitting there under the tree, yes, according to Einstein, it was not that the apple fell on his head rushed up and hit the apple. And that's Einstein's view. Now, I can show you this thing.
Yeah,
right.
You can show us.
Can you bring my little water thingy out there, whoever may be backstage listening to us? Right, here we go. So this idea of getting rid of gravity by going into freely falling motion can be illustrated by a little experiment. So I'm going to do it because I don't want you to get all wet. So what I'm going to do is let me describe it first. When I take off this cap, air pressure is going to be entering into the bottle, and water is going to spew out a few holes that I have here because gravity is going to pull down on the water. And then what I'm going to do is I'm going to let the bottle go into free fall and watch that the water won't spray out any longer. Right? So that's what you should look for. Okay, here we go. All right? So here goes the water. Oh, sorry about that. Right. So now watch when I let it go.
Holy moly!
See that, right? One more time.
Gravity goes away.
Right. See, there it is. All right.
Now, that's a great trick.
Yeah, it is.
Einstein,
right?
Can you explain why we just saw what we saw?
Yeah, so as the bottle is in free fall, it no longer feels the force of gravity, right? I mean, another way of thinking about it that maybe is even, more visceral than this little demonstration is, if you are standing on a scale, right? You look down, you see whatever, 150, 160 pounds for me, something like that, right? If I jump out of the window with the scale at my feet and I look down on it, what does the reading go to? It goes to 0. Because the scale and me, we are moving together. So in that sense, I'm no longer pushing on the scale. I'm no longer experiencing gravity as I did when I'm standing here on the stage. So if you can counter gravity, if you can cancel it out by going into this motion, Einstein realized the reverse was also true. You could mock up gravity. You could simulate gravity by accelerating too.
So that's where you get to a car turning.
Exactly.
And you feel it's no longer what you feel in an elevator, which is nothing.
Yes.
And even though you and the elevator are falling.
That's right. If you cut the cable of an elevator, then indeed you and the elevator will fall together, just like the water in the bottle fall together, just like the scale and my feet fall together, and you don't feel anything. The exact reverse of that is, now take an elevator, an empty space, no gravity, empty space, and pull up on the cable, making the elevator accelerate in that direction. If you're in that elevator, you will now feel your feet pressing against the floor because the floor is pushing up against you. You will have simulated gravity. Why is that important? Einstein understands motion really well, but he doesn't understand gravity. Now he has reduced gravity to motion, accelerated motion. That gives him a way in, and it does take him a good 8 years to fill in all the details, but that yields the general theory of relativity.
But you just said Einstein didn't understand gravity very well.
He didn't in 1907. 1915, he takes this idea and parlays it into a single equation that describes the force of gravity in a way that had never been achieved.
I want to talk about space not as spin-offs, not as industry, not as weather satellite. No. I want to talk to you about space as culture. Space as culture. You know, the first hunk of hardware that had the power to exit Earth's atmosphere, that was the V2 rocket, of course. Everybody knew Wernher von Braun all the way down. Everybody knew that if we have any future in space, it's going to have to borrow some of that technology, if not all of it. The 1950s descends upon us. You remember the V2 rocket? It was kind of bullet-shaped, had these huge fins. Fins. Cars had fins in the 1950s. Where do you think those fins came from? All right, I propose the experiment. You could probably dig up the designers of those cars and they'll say, well, fins just kind of look cool. They're probably not even thinking about the fins of the V2 rocket. They're probably not even thinking about it, all right? And if it's there, maybe it's just not in their frontal lobe. But our cars had fins. When did the fins go away? After we learned that the V2 shape and those fins, that's not quite the rocket we're going to need to get to the moon. Our rockets start looking like the Saturn V rather than the V2. By the way, that V2 rocket shape, that was the rocket in every science fiction story told in the 1950s. Just go back, rent any movie on Netflix from that era, their rockets got fins. I have two books, Bob Barr Goes to the Moon and Tintin Goes to the Moon. They're in rockets with fins. I collect stuff like that. Saturn V emerges. The fins go away. What happened to those fins on the Bel Air and on the 57 Chevy? They're all gone. Oh, so maybe the designer just felt, oh, it's played itself out. Or maybe deep down inside, space was operating on their creativity. So what happens? The 60s are underway. We're going to the moon in a big way. Everybody knows it. We are innovating. We have an innovative culture. You know it's an innovative culture because every week, every month, a new advance in space garners the headlines. Because a space frontier is being breached. A space frontier. And when you breach a space frontier, there's something new to talk about in that day's paper. Something new to talk about. Every next Gemini mission more ambitious than the previous one. Typically redoing what did before, and then it went a little extra, a little farther, a little extra docking maneuver. We're ready to transition out of Gemini to Apollo. Let's launch the Apollo rocket, minus one of the stages. Now let's put in all three stages. Let's actually go to the moon. Don't land yet, because we're still working that. Well, when was that? That was 1968. I'll get back to that in a minute. What else was going on in the 60s? Everybody was dreaming about tomorrow. Everybody. That's what the World's Fair was all about. It wasn't about yesterday. It wasn't about today. It was about tomorrow. The kind of tomorrow that could only be brought into the present by the ingenuity of scientists and engineers. And people knew this. How else is space influencing? Okay, how about the Unisphere? Gorgeous steel Earth sitting there. It's got 3 rings around it. Okay, go to the designer and they'll say, well, I just put on the rings. Well, did the 3 orbits of John Glenn influence? Oh, well, I don't know, I don't think so. But it's got 3 rings, not 2, not 4, and the rings are not going polar, they're going equatorial. 3 rings around an Earth. 1964, New York World's Fair. The 1960s is the bloodiest decade in American history since the Civil War, since the 1860s. Servicemen killed weekly, reported in the weekly papers. Campus unrest, civil rights movement playing out in the weekly news. That's the 1960s. The bloodiest year in that bloodiest decade? 1968. The Tet Offensive in February of that year. Martin Luther King assassinated, RFK assassinated. Yet, somehow we managed to still dream about tomorrow. It was still in us. It still mattered. It's what birthed the Star Trek television series. By my measure, one of the greatest television shows ever, The Twilight Zone, was heavily influenced by space themes. Every 3rd episode, there's some space concept being delivered to you, telling another story through the lens of a space story. Our presence in space is affecting not only the engineers and the mathematicians and the scientists, it's affecting the creative dimension of that which we call culture. We are living it at every turn. Hardly what I call a special interest. What happens December 1968? How do you cap off that year? Apollo 8. An underappreciated Apollo mission, not by this audience, but by anybody else. Most people have never heard of it. Apollo 8, what's that? Excuse me, that was the first time anybody ever left Earth with a destination in mind. Yeah, it figure-8'd around the moon. Photo of Earth rising over the lunar landscape. The photo is really misnamed because the moon is tidally locked to Earth. So Earth is always in the sky on the near side of the moon, always. So it only was rising because, in fact, they were figure-8'ing around the moon and Earth rose up. That photo, we all know it. Earthrise over the moon. There was Earth, seen not as the map maker would have you identify it. No, the countries were not color-coded with boundaries. It was seen as nature intended it to be viewed. Oceans, land, clouds. We went to the moon and we discovered Earth. I claim we discovered Earth for the first time. How does that affect culture? I got a list. You could take apart this list and come up with an explanation that does not directly reference space for everything on this list. You could probably do that. But I take a step back and I look at that list and I say, wait a minute. Wait a minute, how is it? Let's back up to 1962 briefly. Rachel Carson publishes Silent Spring. The Green movement typically credits that as the birth of ecology, the birth of caring about the environment. It was a best-selling book. I have a different view. Maybe it planted some seeds, maybe it tilled the landscape, but stuff didn't really start happening until after that photo of Earthrise over the moon was published. 1968, the whole Earth catalog is published. There's a version before that photo is printed. The instant that photo comes out, that is the identifying cover picture of the whole Earth catalog. Thinking about Earth as a whole, not as a place where nations war, as a whole. 7 months later, 1969, we land on the moon. 1970, we're still going to the moon. We go until 1972, so watch this sequence of events. 1970, the Comprehensive Clean Air Act is passed. There were two other versions of that in the 60s, 1963 and 67, but the most important rendering of that act came in 1970. Earth Day was birthed March 1970. The Environmental Protection Agency was founded in 1970. There was a film called The Hellstrom Chronicle. It was one of the first pseudo-documentaries to actually get first run in the theaters. It was all about insects, it was a scare movie about insects and what role they might play on our food supply as we go forward. But it got us thinking about nature. The organization Doctors Without Borders was founded in 1971. Where do you even get that phrase from? No one thought of that phrase before that photo was published. Because every globe in your classroom has countries painted on it. Doctors Without Borders, 1971. DDT gets banned, not right after Rachel Carson's book, gets banned in 1972. We're still going to the moon. We're still looking back to Earth. Clean Water Act, 1971, 1972. Endangered Species Act, two versions of that in the 1960s. The most comprehensive version, 1973. The catalytic converter gets put in 1973. Unleaded gas, 1973. We're still at war in Vietnam. There's still campus unrest. Yet we found the time to start thinking about Earth. That is space operating on our culture, and you cannot even put a price on that. That is a nation, that is a world reacting to a new perspective on what it is to be alive on this planet that we all share. The knowledge that the atoms that comprise life on Earth, the atoms that make up the human body, are traceable to the crucibles that cooked light elements into heavy elements in their core under extreme temperatures and pressures. These stars, the high mass ones among them, went unstable in their later years. They collapsed and then exploded, scattering their enriched guts across the galaxy. Guts made of carbon, nitrogen, oxygen, and all the fundamental ingredients of life itself. These ingredients become part of gas clouds that condense, collapse, form the next generation of solar systems, stars with orbiting planets. And those planets now have the ingredients for life itself. So that when I look up at the night sky, and I know that, yes, we are part of this universe, we are in this universe, but perhaps more important than both of those facts is that the universe is in us. When I reflect on that fact, I look up. Many people feel small because they're small and the universe is big, but I feel big because my atoms came from those stars. There's a level of connectivity. That's really what you want in life. You want to feel connected. You want to feel relevant. You want to feel like You're a participant in the goings-on of activities and events around you. That's precisely what we are, just by being alive.